Hello, welcome back to Cracking the Cryptic, and it's time for another dose of gas for me, by which I mean I'm going to be attempting another 5 genuinely approachable Sudoku puzzles from the daily puzzle channel on Discord. And these puzzles are prepared on rotation by Philip Newman, Clover, and Sam Kappelman Lines, and I'm still trying to keep up with the series. I probably haven't advanced this week. I think it's probably 5 days since I did the last one, but we are going to do another 5, and really looking forward to it. These are always very popular, partly because the rules are relatively simple, partly because the puzzles are genuinely approachable, it's in the name, and partly because the constructors are so good at what they do. So what I shall do is, in a moment, I'll run through the rules of the 5 puzzles that we'll be attempting. Then I will try them pretty much as fast as I can, not far off that anyway. And then maybe a very quick review, but nothing guaranteed about that. Now, obviously there are a number of things going on, including Grokkel's Heatwave Sudoku Hunt or Relay, which is available on Patreon. So for all our Patreons, if you are supporting the channel, and thank you very much if you are, you can have a go at that until the 20th. That will be the closing date for a prize selection. We always get quite a few answers in after the closing date, and they're very welcome as well, but they're not eligible for the draw. Also, of course, we have our Sudoku Pad app from Sven's wonderful work on the Sudoku Pad. Also, Sven mentions there's very few reviews on iOS on the App Store. So please, if you've enjoyed the app, it would help other people find it and realize they would like it too if you were to leave a review. But that's up to you. Now, there's also all our other apps: Sandwich, Killer, Chess, Classic, etc., available on the links under the video. And what else? That's it, really. Discord. I mean, you can look at the links under the video and find what's there. So let's have a look at these 5 puzzles. And they start with Badge by Philip Newman. Now, this is just a killer Sudoku. Digits in the cages, can't include repeats, and their sums are given. And this is terrifying, because I think Simon did a 17-cell cage killer by Philip before, and it was hard. So I'm a bit scared about that. Now, in this next one, this is called Search 9 Sudoku by Clover. A digit in an arrow cell. You can just see these arrow cells here, and this is on a... The guys themselves have now started supplying links to the puzzles in our software, so I'm using their version. I might actually change it up in a moment and make the arrows a bit clearer, because I think they're very unclear. The way that it works is, if there is an arrow in a cell and there's a downward pointing one in this cell, then whatever number is in that indicates how many cells in that direction till you hit the 9. So if that was a 4, 1, 2, 3, there'd be a 9 there. That's what the arrows mean. Normal Sudoku rules apply. I will pause in a moment and substitute in a different version of that. So let me arrange that. Now, then we have Consecutive Circles Sudoku by Sam. Each marked circle must contain a sequence of consecutive digits. The starting point and direction are unknown. So it's not quite Renban, it's not quite Thermo, but a sequence of consecutive digits and in order. So let's pick a small one. 1, 2, 3, 4 would be possible on that. But it might not begin with 1, it might not start there. It might not go clockwise, or in fact anti-clockwise was my example, but it might not do that. Right, on to SquareShapedBox by Philip Newman. Within cages, digits cannot repeat and must increase from left to right in rows and top to bottom. So it's like, you can imagine a thermo going that way and that way and that way, and another one going that way and that way and that way, and that applies to each marked cage or box. And then finally, loads of markings on this one. Consec-Pairrow by Clover. Digits along an arrow must sum to the digit in the adjoining circle. That's kind of normal arrow Sudoku. Those 3 add up to that one. Digits separated by the white dots must be consecutive. Not all dots are given. Fair enough. Now, I'll be back with you in a second after I've created this other puzzle, which will be useful. I'm just going to replace this grid. Hang on one sec. There we go. So this is the grid in our software. Anyway, we will get to that second. This is the first one, Badge by Philip Newman. Now, what I shall try and remember to do is to restart my clock so that I know how long I'm taking as I solve it. I will also put a timer on, so even if I forget to do that, you'll see how long I take with each of them. And hopefully one of these guys will grade me on, in terms of 2 hats for a fast time, 1 hat for a decent time, and a dinosaur for any solution. Right, here we go. Let's get cracking. Now, this is just... Oh, I'm a bit nervous that this is the actual puzzle that Simon solved. It looks in shape a bit like it, but no, maybe it's not. Sorry, I think I'm over worrying. We get 9, 8, 6 there, 9, 7 here. That is a 9, 8 pair, so it makes that 6. Now we've got a 9, 8 pair there, so this is resolved, 7 and 9. Don't know what to do with 5 and 6. If that was 2, 3. Yeah, that's interesting. It can't be 2 there and 3 there, because this would have to be 4 or 5, and that digit would then clash with the 2, 1 pair. So it's not a 2, 3, so that's 4, 1. 3, 1 there. I've somehow grayed that cell. I don't even know how I did it, but I'm not going to worry. This is now 4. It can't be 5 because that can't be a 1. Oh, that's become an 8. So we are nearly done with these. None of those can be a 1 because of these ones. So they are a 2, 3, 4 triple. Currently chocolate teapot fashion. But let's see if we are now... I don't know. How are we meant to find the rest? That's got to be 9 in the bottom row. Okay, so 9s are beginning to go in. Ah, look, one of those has to be a 9. So that becomes 9, that becomes 9, and that and that. So 9s are done. That's beautiful. What digit have we got a lot of? 1s. There's a 1 somewhere down there. I don't know. That might not be the right digit to look at. 8s. They're all ruled out. So we've got an 8 in one of those. That's 8 as a result. One of those becomes an 8. That becomes an 8. Oh, it's so pretty. 8 there. That does fix the 1s. That'll probably be helpful in a moment. We get 8 in box 3 and box 2. That's an 8, and suddenly all the 8s are finished. I mean, it's amazing that this can solve this quickly with so little apparent information. 7 goes there. This is a 4, 5, 6 triple. We've got a 2, 3 pair. Let's observe that 2, 3 pair. Ah, it doesn't quite resolve 5, 6, and 7 in those cells. Might be pointless to... That's where 7 goes in this column. So 6 and 5. This is now a 2, 3 pair. How are they ever going to be resolved? 4, 5, and 6 in a triple. 8, 9, 3, no, 7. Let's look up here. Where can 7 go? It's got to be there. So that fixes that as a 7. That makes this a 7 in box 1. Then we get 7 in one of those two. And a 7 in one of those two. I have to stop with 7s now. 7, 8, 9, 3, 1. 6, 3, and 5. That is 3 or 5. What about this box then? 8, 9, 6, 7. Ah, 2, 4, 3 as a triple. Right. So 6 is down here somewhere. That is 1 or 5. It's not quite enough to go on. I mean, I'm still really having trouble believing that this solves uniquely, but I suppose it must. Right, 4 can't be there, and it can't be there because of the triple. So one of those is a 4. Ah, and that actually puts 4 here in box 4. Wow. Yeah, one of those is a 4. Don't know what to do with that. 9, 4, 7, 6, 8. 1, 2, 3, and 5. That's not a helpful group. Right, 2 can't be there, also can't be there. So that's a 2, 4 pair. That is less helpful because I don't know where the 2 goes in which box there. 2, 4, 9, 8. So 3 now has to be in one of those cells. 7, 8, 2, 4, 6. These are from 1, 3, and 5. Yes, 2 there places the 2 in this box. Now that undoes my chocolate teapot. That's not a 4. 5, 2, and 6. 8, 3, 4, 9, 7. Ah, 6 in box 1 is there. Yes, sorry. Oh, hang on. I don't want to make a mistake here. I think I took 2 out of there unwarrantedly. I should have been taking 6 out. So I've got a 2, 1, 5 triple. In fact, that's a 5, that's a 2, that's a 1. Whew! Caught that as I did it. That's not 2. Right, 9, 3, 5, 1, 2, 8. 6, 8, 1, 9, 7. No. This is the last one in its column. That's a 3. 3, 2, 4, 9, 8, 1, 5, 6, 7. Oh, come on. Yes, the 2 is looking across there. So that gets that as a 3. Now 2 in the central box is there. That's a 2. One of those is a 3. One of these is a 7. I still think this column 6 ought to have gone by now. Yeah, 3, 5 pair. So that's a 6. It was looking for a 6 in that box would have helped. Now I've got a 6, 7 pair, so I can fill in 1 and 5. This is actually going to finish now. That is suddenly clear, astonishingly. What a puzzle. I mean, what a creation. I know that Philip, to some extent, deploys computer tools to create this grid, but frankly, that is an impressive skill in itself. A massive one, absolutely massive one. And when it creates grids that are this fun and this incredible to see, it really is to be admired. That's a 1, 9, 6, 7, 8, 1, 2. That is 3 or 4. So 5 goes there. That's going to resolve the middle box and the right-hand box. That can't be a 6, so that can't be a 4. So that sorts this triple, this cell. They're resolved by the 7. They're resolved by the 5. Now we can do these, and it does finish with absolute beauty all the way through. What a puzzle. Love that. And time of 7 minutes 16. I mean, it's not bad, but when you imagine that there's only 17 cells covered by the cages, you can't even, you probably know that 17 cells is the minimum to create a Sudoku grid, but this has fewer because you can't actually fill those in from the start in the 9 cage. So it's got like 16 2/3 or something cells. Oh, amazing. Absolutely amazing. That puzzle is worth doing all day long. Anyway, let's move on to this search 9. Right, now, as I said, the rules are if you have a 1 there, it says there's a 9 1 cell away in that direction. So let's restart the clock. Here we go. Oh, how do we go? Don't know. 9 can never be in an arrow cell. So 9 in the bottom row is in one of those places. 9 in the middle box. In box 8 is in one of those 2. That's not really how to do it. They're 1 apart. And this is pointing up and those are pointing down. 9 can't be there. So if 9 was there, that would be a 3. That's no good. If 9 was here, one of these would be a 5. That's no good. So 9 is in one of these 2 cells in column 3. That's a 1 or a 2. That's looking down at them. 1, 2, 3, 4. Well, it can't be there, or that would be a 5. So 9 is here. 1 is here. This is a 6 with a 7 above it. And that whole column works. Now, let's work the same magic here. Here it's harder for them to be 7s or 5s. If that was a 9, one of them would be a 7. If that was a 9, that would be a 5. And that would be a 5. So 9 has to be here. 2 and 3 above. This is 5 away. And we're okay. This is a 5 by Sudoku. Oh, this can't be a 1 now, so it must be a 2 with 9 there. Arrows pointing a short distance are very useful. Oh, look, that's pointing at a 9. Should have seen that a long time ago. Now, that makes that a naked single 8. We've got 3 and 4 there. That's a 2 with a 4-9 pair above it. This is now 3, 6, 7, or 8. Well, it has to be 7 or 8 to hit the 9. 2, 3, 4. One of those is a 1. Oh, we know what this is because we know where 9 is. 1, 2, 6, that must be. This is pointing at a 9. That has to be here because of that pencil marking. So we get a 2 there. Then we can put in 1 and 2 down here. This is pointing at a 9. That gets a 3. Where is the 9 in this column? It's in one of those 2 cells. So these, 1, 2, 3, 4, 5, 6. That has to be 7 and 8 with 9 at the very top. That fixes the 9 and 4 there. Now we know that this is a 7. This is either pointing 1, 2 up. It is. And that's all the arrow cells done. So the rest is silence. No, the rest is classic Sudoku, I think. 1, 4, 7. We've got a 2 and a 6. They go in straightforwardly. What about these two? Oh yes, 9 I haven't put in there. So that's a 3. We've got 3 and 6 in the corners. Losing their religion. That's a 2, 4 pair with a 7, 8 pair above it. This must be 1 and 6. 3 and 8 to go in there. 8, 1, 6. 4 and 7. This is really just straightforward classic Sudoku. Just basic eliminations. 3 must go there. 7 and 5. 8 must be there. We can even flank it with its 1 and 2. This 8, 7 pair has been resolved. 8 to finish its row. We've got 6, 1 pair there. 4, 5 and 7. And 1, 5 and 8 at the top. So that is done in just under 4 minutes. So that was pretty straightforward, even though I missed the most obvious arrow for a little while. But they're not too difficult once you do some thinking about columns 3 and 7 particularly. Work out the possibilities. Very nicely set puzzle there. And now we can move on. I'm a bit nervous about this. Consecutive circles. Okay, let's restart the clock. I mean, I guess the thing to think about is these big ones. They've got to have 2, 3, 4, 5, 6, 7, 8 on. So 4 is in one of those cells, but 5 can't be. So 4 is in one of those. 5 can't be in one of those two. Oh, so 4 is in one of those. No, it could be a 4, 5 pair there. That would need 6, 7. That's going to break with 8. Can't be 6 there. So 4, 5 aren't down here. 4 can't be there with 5 there. So I think 4 has to be over on this side. I think this is right. And 5's in one of those two positions with 6 coming after it. This is the 7, 8 pair. It can't therefore have a 9 in either position. So this is a 1 to 6 circle. So the 1's are in those two cells with the 6's. That's the 2, 5 pair. This is now a 3, 4 pair. And that can't be a 1. So 6, 5, 6, 5, 4, 3, 2, 1. Get these in the right order. 8, 7. And I think that all works. Now, so 3 in that column, that row is there. 2, that's a 7 or 8. That's a 2 or 8. That's 2, 7 or 8. That's not so helpful. Let's look at this circle then with a 5 or 6 there. So what's this going to be? It can't be bigger because it would be 6 or 7. So it has to be smaller and it can't be 4. So we get, oh, hang on. It could be the end. In which case it could go 2, 3, 4, 5 or 3, 4, 5, 6. No, those aren't possible. So that is a 5. This is a 6. That can't be a 4. So that's the end. 7, 8. And I think that must be right as well. It does bear in on me that it's not impossible. I wasn't thinking through all the possibilities. But I think I'm okay. I'm risking it anyway. 5, 8, 6, 4, 7. If I have to kind of go back in this, I will go back to the very start. Right, those neither can be a 3 or a 1. So 1 is here in this row. And that fixes that quadruple. 6, 1, 2, 3, 7, 8. This is 4, 5, or 9. Now, can I relate that to this? Not very easily. Oh, look, this can't have a 1 in. That's probably the simplest place to start. So it's definitely 2 to 9. 2 has to be in one of these cells. But if it was there or there, 3 would be impossible. So 2's in one of those. With a 3 somewhere past it, away from that 3. So then 4 is in one of those, and 5 is in one of those, and the 5 must be here. So that's the 4, 3, 2. Let's just get rid of those. We go 6, 7, 8, 9, and I think that all works, so I think that's correct. 4, 1, 7 there. I've got 5, 8, and 4. That's a 4. 8, 5. This becomes 9. 3 and 6 still to go in the box. Oh, we've still got a circle to do. I don't know if we'll need it really. That might just be Sam's skill in compiling there. Now, 9, 1, 6. 4, 3, 2, and 9 to go here, and they're another triple that I can't resolve. That's a 2 though, so let's finish off down here if we can. 1 and 9, that makes that 2, that's right. 7 and 8. 3 and 4, and I can't do those yet. Now I am going to need this other circle because Sam is very clever. That is now 5 or 4, so this obviously goes, oh well, 8 there, so this is 7 on the circle, so we must go down 6, 5, that's fine. Okay, that wasn't that hard in the end. 8, 3, 4, and 7 up here, 7, 4, 3, 1, 2, and 9 to fit in, 9 in the centre of the circle, 1 and 2, so we can sort out 6 and 3. Now we can do this row, 3, 9, this row is a 4, 2, and 4 and 3 to finish. Oh, what have I? Wow. Okay, well that was rubbish, wasn't it? I said I would go back to the start if I got it wrong, and I think I'm going to have to do that. Ow. So 5.5 minutes wasted. So maybe I missed a possibility at the start. It's possible I just typed a wrong digit somewhere towards the end. Let's start up here this time. There's no 1. 2 has to be in one of those, but to accommodate 3, I think this is still right. 2 there, 3 in one of those cells, 4 in one of those, 5 again in one of those, but that has to be here. I'm sure that's right. 4, 3, 2, there's no 1, 9, 8, 7, 6. Let's do this quadruple marking. 6, 1, 7, 8, 3. So 4 has to be there in the row. We've got a 5, 8 pair. It's weird. That went so well last time. I almost think maybe I did just make a tiny mistake. Ooh, 9 on that. So it's got to be a 9, 8, 7, 6 circle. And that looks like it works. That's a 1, 7 pair. This is a 4, 5 pair. 9 there with 2 and 6 either side. 1, 4, and 3 to go. And we can see that 1 goes there with a 3, 4 pair here. That seems familiar. 6, 7, 9. That's 2 or 3. So 1 is definitely in one of these cells, and that's quite important on this old wheel here. Can't be next to a 3 on the circle, so it's 1 and 2 there. That's a 3. That's 2 or 8. That's 2, 5 or 8. Now 3 is in one of those two, and 4 has to be here. It can't be over there. So we know which way round this goes. 5, 6, 7, 8. So as long as I have understood the rule, that has to be right. Now we can do 1, 3, 4, 2. That fixes this 6 and 2 pair, 8 and 7 there. 5 and 2. This feels like it's working. I've written the wrong candidates in here, but out of 8, 5 and 2, that's right. Yeah, maybe I haven't, I don't know. 8 and 7 at the top. 1, 6 and 9 in this column. Now 4, 5 and 9, that's a 9, that's a 4, this is a 5, so that has to be a 7, it can't be an 8, this is an 8, that's a 6. This has to be working now. I don't know what I did wrong last time, and I apologise for it. 7, 4, 3, 6, 8, 5, we get a 9 there, 1 and 2, 5 there, 6 and 3, 3, 9, 4, 2, and 4 and 3. There we go. I don't know how different that is from my first attempt, but we can add those 3 minutes to my 5.5, and it's an 8.5 minute solve. Okay, let's try the next one. After that one beat me up a bit. Right, this is the square-shaped box with the kind of imaginary thermos, a bit like the, what was it, Young tableau that Simon solved, I think. So, anyway, let's have a go at this. Restart, and okay, these 3-cell or 9-cell cages have to have 1 and 9 in the top left and bottom right, respectively. 3 there, so I don't know. Okay, 2 can't be there. I think that means it must be here in the cage. 3 can't be there, but it could be in either of those positions. Do I pencil mark the whole cage? Tempting being me, but maybe I won't. Where does 8 go? Oh, where can 8 go? Oh, 8 can go here. I thought it was ruled out of both of those cells, which would be impossible. Then where does 7 go? Not there or there, so that's 7. Ah, this is the place that I should have started. 6 can't be there or there. I think it has to be here, therefore, yes. Probably can't do the rest, although those are smaller than the ones on the outside. But now, do they help? 7s, 6s, 8s, not very much. Not as much as I'd like. Maybe I'm missing something up here. 8's in one of those. 3 is in one of those. 4 can't be there, but since 3 could be there, 4 can be in either of those places. Probably not anywhere else. Oh, it could be there as well. No, that's not the way to do it. 3, 5, 6 or 7 there, but this has to be bigger. 5, 6, 7 or 8. 3, 5, 6, 7 there as well. Right, so 1 is in one of those positions. And then one of those. Oh, 2 can't be there, so that's a 2. Then 2 ends up in one of those 2. 3 can't be there, so I think it has to be here. Yeah. 4 can't be there, so it has to be here. 5 can't be there, so it has to be here. Oh, and 8 and 7 finish off. It was the middle box was where to start. Oh, I'm so slow sometimes. Right, that's not a 3. 7, 9, 8. So one of those is a 3. Okay, what about this? 3, 1, 2, 5, 7, 9. So that's 4, 6, or 8, but it can't be 8 because this has to be bigger. 5 or 7 there. 2, 3, 6, 8, 5 has to be bigger than 3, but smaller than 7. I think it has to be a 4. 2, 3, 5, 6, 8. Yes. 4 there, 6 there. That's now a 7. This is an interesting one. I mean, it's not hard, but I have not been taking a great approach to it because it's a bit unpredictable, frankly. 4 and 9. Well, that can't be 9, so we can do that. 1, 2, and 5 there. This has to be less than 4, and this is in between that and 7. Now, 8, 5, 4, or 3 there. Can't be a 1. That has to be smaller. 1, 3, or 4. Ooh, this sees 1, 2, 3, 4, 6, 7, 8. So that's a 5. That's not a 5 because of the rule about repeating in cages. So, what does that tell us? Oh, 6, 4, 5, 8, 9, 7, 2. These are from 1, 3, and 6. 9 must be in one of those two cells, which doesn't matter in that box, but it places 9 there for sure. That can't be a 4. And that can't be 1 or 2. They're not quite working yet. That's not a 5 now. So this now has to be 8. Probably had to be, well, that could be a 5. So this isn't 8, this is 8. So where's 7? Oh no, it could be there. No, it couldn't, because that would have to be bigger. So 7 is there. That makes this a 6. Wow, I like this puzzle. It is not unfolding in the way I expected at all. They can't have a 6, so that's a 5. This is a 2, 6 pair. We can do that from the 6 in the corner that's given. 3 or 4 there, 1, 3 or 4 on those cells. That's not a 1. Though that's not a 3. I think that means this has to be the other of 2 or 3, and that has to be the other of 4 and 5. Let's have a look at the top. Maybe this box. That is now a 6, naked single. Wow. Wasn't expecting that. This is 3 or 5, and I think both of those work. In fact, it's got to be 5 because that 5 says so. So now we can put in 3 and 4 there, and we must be on the home straight now. We've got a 5, 8, 9 triple in this row, then 1, 3 and 4, and that can't be a 1, so that's a 1. 3, 4 pair, so 2, 5 there, 3, 4 there. That fixes the 3, 4 pair. 3, 4, 1 there. This can't be a 2, that can't be a 5. This can't be a 2, that can't be a 5. Come on, do this the sensible way. 1 and 3 have been resolved. 3 and 8, so I can do my row 8 now, and that's going to pick up all my remaining doubts. I think 4 and 2 there. 5 and, oh, I was going to say 6, no, 7. There we go. Okay, that's right. Just under 7 minutes. That's a really nice puzzle. It did not unfold in any way that I was sort of expecting. You had to start in the middle. I could have done better with that, but then things actually feed into the other small squares as well. Very clever, really enjoyable. Let's move on to the 5th one. Feeling a little bit the worse for wear at this stage. Now, Consec-Pairrow. Okay, we've got arrow Sudoku and crop key consecutive dots. Let's restart the clock and let's go. Right, that has to be a C. Oh, these 3 are in sequence and add to that. So they're either 1, 2, 3 or 2, 3, 4. We don't know the order, but that's either 2 or 3. Now, are there other arrows like that? Yes, there's what's set. So that's 6 or 9. There's a set, so that's 6 or 9. So these two in between are 6 and 9, must be 7 and 8. Oh, this is a set of 4. 2 and 3 are involved there. So this cell is 1, 4, or 5. This is on an arrow and a dot with it. Oh, come on, I'm not looking at this the right way at all. Right, 6 or 9 there. 6, 7, 8, 9, 5, 4 there, 3, 2, 1. That would work. 9, 8, 7, 6. 6 can't be there because those must be odd. But 6, 5, 4, 3 with a 2, 1 pair here would work with an... Oh no, that is next to that as well. So that won't work. Right. So this is a 6 going up to a 9. I think that's the only possibility. This is a 4-5 pair. This must be 3, so we know which way round the 4-5 pair go. That's a 1 with a 2 there. So this group is a 2, 3, 4 arrow, making 9, which tells us the order of the rest. This is a 2, 1, 3 arrow down here, but that's consecutive, so we get a 4, 5 there. This is an 8 with 7 or 9. So this is either 3, 4 or 4, 5. This cell is a 5, so that's a 4. Then we have to go up 6, 7, 8. Now we've got a 9 and a 3 here. No, a 9 and an 8. That must be 9 because it must be odd. So these can be consecutive. 4 and 5 there, 2 there. 3, 2, 9, 4, 5, 6, 1. So this is 8 or 7. We don't get the dot to make it easier. 6. So this is a 1, 2, 3 set. In fact, that has to be a 1. That's a 3. That doesn't have a 3, so it's 4, 5, making 9. Now, what's happening here? It can't go up from 4, 5, so it must go down. 5, 4, 3, 2, 1. What have we got left? 6 and 1. That has to be a 6. Don't know whether that's 1, 5 or 2, 4. So 7 and 8 here. That forms a 7, 8 pair. And this can't have a 1 or a 2 in it. So it's either 3, 4 or 3, 5. 3 there, 4 or 5 here. And this, oh, this could have a 1 in it, and it now can't have a 2 or a 3 in it. So it does have a 1 in it, and it's either 1, 6 or 1, 7. Can't be 1, 7 because of the pair. So it's 1, 6, and that's a 7. That makes this an 8. That sorts out the other uncertains in this box. 4, 2, that's 3 or 5. 9 and 6 there. 4 and 1. What have we got? 9 and 5 at the top. 1 and 2. 1, 2, 8, 5, 4, 9. 3, 6 and 7 to go in there. That one can't be a 3. That 4, 5 is still not resolved. Nor is this cell, but these are a 4, 9 pair. We can do those. 4, 4, no, they're done. 9. Right, this is 8 and 6 in that row. This is 9 and 5. 3 and 4 we can do. We've got 2, 7, 9 triple. I can put them in. Yes. Now I've done the 4, 5. Has this got resolved? No, it's part of a 1, 6 pair with 8 there. That's become a 7. But 6, 3 pairs not resolved. Ah, that's now become a 1. There we go. 9, 8, 1, 3, 5 and 6. So that's a 5, making that a 3. 6 there. 2, 8 and 7 above. And a 3, 6 pair to finish off. And there we go. That one just over 5 minutes. Good fun. I mean, not too hard. Even if you're a bit of a beginner, you'll find your way through that if you just keep concentrating. And it's a really nice puzzle. frankly, this set was amazing. I thought they were brilliant. That's incredible. Just because of the absolute dearth of information. That was good fun. Really like that. I mean, Search 9 has troubled me in competition before, but that was good. This was very clever. I will review it afterwards and see where I went wrong in the first attempt. Certainly wasted some time, but it's certainly not the puzzle's fault. That's entirely on me. This was very interesting. I was quite surprised how that worked. And this was lovely. I mean, a really good set of puzzles. I do hope you've had a go at that. I hope you've enjoyed, if you've watched me throughout, I hope you've enjoyed that. But certainly I hope that you enjoyed having a go at them, because they are good. And with that, I shall say see you next time. And thank you very much for watching as always. Bye for now.